Okay, so today we're going to do the LeetCode again. Um, the problem is this 326 part of 3 easy question. I love easy question. So let's take a look at the problem set. It says given an integer n, okay, so that's going to be our input. We have to return true if it is a part of 3. Otherwise return false. So it's a math question. It's a programming question. It's a math question. This is the type of question I really hate. Um, so second sentence, an integer n is a part of 3 if there exists an integer x such that n is equal to 3 to the power of x. Such that sentence. Math sentence. I hate that. Let's take a look at the example because that's too philosophical. So if the given integer n is 27, we have to return true. Yeah, that sounds like kind of a 3 thing. So let me check about that. So if n is 27, 27 is 3 multiplied by 3 multiplied by 3. So we can write that to 3 to the power of 3. Okay, so this is true. Go to the next example. N equal to 0, we have to return false. So is that true? So equals 0. Basically we cannot, right? Basically we cannot because even though we choose part of, for example, 0, we only end up with making 1 and we cannot make 0. So yeah, 0, so we cannot make it. Let's go to the next example. So n equal 9, true. Yeah, that looks like a correct answer. If the input is n is 9, you can say that's 3 multiplied by 3, so that's 3 to the power of 2. So that's true. How about the last example? N equals 45. Equal 45. That's that's first you divide it by 3, and you can get the 15. So we can divide by 3 again, but that's going to be 15 divided by 3 is 5. So this is 3 to the power of 2 multiplied by 5. So this is not a power of 3. So we have to return false. Okay. We have one constraint. The n could be very huge. And also it could be negative. Can we make it negative? By to the power of 3. So basically we cannot, right? So even though we choose, 0, this is just 1. And even though I choose 1, this is 3, obviously. And then even though I choose negative number to the power, this end up with 1 over 3. So this is all the time going to be positive. So we cannot make negative number. So as long as the given integer n is negative, we have to return true, the fourth. Okay, so that's a good information. So what we have to do is we have to make the kind of rule to return true or fourth. So I think we do it in this kind of dividing so many times. So I think this is a good starting point. So if 27 divided by 3, this is going to be 9, and then remainder is 0. And then 9 divided by 3 is 3, and remainder is 0. And then 3 divided by 3 is 1, and remainder is 0 again. And 1 divided by 3 is 0, and remainder there is what? is 3. Okay. And then we're going to do the 9, but we already have this, so we can copy and paste this here. And then we also have example 45. So if we divide it by 3, this is going to be 15, right? And the remainder is 0. And then 15 divided by 3 is 5, and remainder is 0 again. And 5 divided by 3 is 1, and remainder is 2. Okay. And then 1 divided by 3 is 0. Remainder is 3. So yeah, so I think the pattern here is we just keep dividing by the given integer, keep divided by 3 until the remainder is not 0. Here, 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 and then if the answer is 1, that's power of 3. And if it is not 1, that's not a power of 3. So that's the kind of pattern that we can observe from the example, and then we have to make that to the program. So let me use the IDE. So copy and paste this, copy and paste, paste, and I don't want these things. So as I mentioned, if the n is 0 or negative, we can just, and also n is supposed to be or it's integer all the time. So we can safely say if the n is smaller than 1, which means negative or 0, we can return false. Okay. And then we can do the pattern thing here. Okay. So we want to keep dividing by 3. So n divided by 3. We want to do this as long as remainder is 0. Okay. So in that case, we use the modulo operator. So as long as n modulo 3 equals 0, we can do this thing. Okay. This curly braces is Java. Okay. As long as I can have some kind of, yeah. So as long as and then when the remainder, yeah. So if we are going to break this while when remainder becomes non-zero. And also we have to get these values, so we have to save that value somewhere. So maybe we can call temp, and then we just keep dividing that. So n equal n divided by 3, right? So yeah, we can check that thing here. So for example, n equal 27 in the while loop, 27 modulo 3 is equal to 0. This is true. And then temp equal to 27 divided by 3 equals 9. Okay. And then n equal to 27 divided by 3 equal to 9. So this is one first iteration, and we go to the next iteration, and then 9 divide no it's modular 9 3 equal to 0. This is true, and then temp is going to be 9 divided by 3 equal to 3. Okay, and then n is updated by 9 divided by 3 equal to 3. Okay, so this is the second iteration, and then we go to the next iteration. This is also true. This is also true. No, damn it, I can't type that. So 3 divided by 3 equal to 1. Okay, this is a pattern thing here, and then n equal to 3 divided by 3 equal to 1. Wait, what? Okay, and then now n equals 1. So 1 modulo 3. This is not 0, right? Because I think we already checked that. This is going to be 0, remainder is 3. So this is 4. So we are going to break for loop, and then now we have n equal to 1. So we can use n. So after breaking the while loop, we are going to just check whether this n is equal to 1. So in the 27 and 9 case, it's going to be 1, so we can return true. And then if the given integer is in 45, the remainder is supposed when we break the while loop, n contains 5, which is not equal to 1, so it's returning false, and then that's indicating that the given integer n is not the power of 3. Maybe we can test that here. So we can make a test case, and then if 27, and then we make the object of solution. So solution, and then maybe we can make output as an answer, and the solution using the method called power of 3, and if the given integer is a test case. Okay, maybe we can print this. Okay, answer. Answer. Okay, so this is supposed to be true. Yeah, we can get true. And then if the test case is 9, this is supposed to be true. This is true. And then if the test case is 45, this is going to be false. This is false. Okay. So I'm gonna just, it seems to be we finished this exercise. So I'm gonna just copy and paste this to the LeetCode website. Check the indentation, and then just run it. Yeah, so a success. So we finished this problem set. Yeah, thank you. That's it. Thank you for listening.